We've started to add some structure to our game engine with game objects and some components. In this video, we're going to continue expanding on this and restructure the engine so that we will be ready to start with 3D rendering in tutorial 12. First, if we take a look at our app implementation class, it is kind of doing a lot. We have the command buffers, swapchain, and draw functionality. These objects all revolve around rendering and would probably be required for any app that wants to display to the screen. So we're going to pull this functionality out of the app implementation and put it into a renderer class. This renderer will be responsible for managing the swapchain, command buffer lifecycles, and drawing a frame. Next, we can see that the application class sets up a pipeline and pipeline layout, and also records to a command buffer how to render the game objects. This functionality can be seen as a rendering system. We will typically only ever have one renderer, but can have multiple rendering systems that can render game objects in a wide variety of ways. But first, allow me to elaborate on what I mean by system in this context. By this, I am not referring to the system portion of an entity component system architecture, even though there are some similarities. I'm going to call anything that acts upon a subset of a game object's components a system. For example, we could have a rainbow system that takes a list of game objects each frame and sets the color component of each game object to a random color. The rainbow system doesn't need to concern itself with rendering or any other parts of the application. All it requires is a list of game objects that have a color component that it can update. Note that not all game objects are compatible with all systems. Game objects may only contain a subset of the possible components. For example, imagine if we have a game object called Invisible Tree, whose model component is a null pointer. Then clearly this game object would not be compatible with the SimpleRenderSystem. Currently, it will be the responsibility of the application to keep track of what game objects are compatible versus incompatible with each system in use. So to avoid confusion, I just want to reiterate this is not an entity component system. We will cover ECS architectural design in a later tutorial. Okay, let's get to coding. We're going to create a renderer class to encapsulate all this functionality, which should make things a lot simpler. So create a new file, lverenderer.hpp, and then I am going to copy my entire first app header and paste it in. Start by updating the class's name from first app to lverenderer. Next, remove the include statements for game object and pipeline since the renderer has no dependencies on them. Following that, we can remove the width and height variables. And then let's delete the run declaration, the load game objects declaration, the create pipeline and pipeline layout declarations, and finally the record command buffer and render game objects declarations. For the member variables, update the window and device variables to references, as we will pass these in through the constructor. Leave the swapchain member as it is, but remove both the pipeline and pipeline layout variables. The command buffers can stay, as it is now the responsibility of this class to manage them and not the application class. Next, delete the game objects member variable, and then we will update the constructor by passing in references to the window and device. So we have LVE window reference window and LVE device reference device. Okay, this is starting to look a bit better, but the draw frame function can't be private if it's going to be called from outside the class. I am going to split the draw frames functionality into two parts, one function to begin the frame and a second function ending the frame. This way, we can start a frame, record whatever we want to the command buffer, and then end the frame having that buffer be executed. So first add a public function that returns a VK command buffer called beginFrame, and then a second function, void endFrame. Now we will no longer require the drawFrame function, so remove that declaration. Since the renderer class manages the swapchain and its render pass, we will also need a begin and end command for recording the swapchain's render pass. So add a void begin swapchain render pass function declaration that takes a VK command buffer argument called command buffer. And I'll just duplicate this line and change begin to end to declare end swapchain render pass. We will need to track the state of the current frame that is in progress. So add a new private member variable of uint32 type called currentImageIndex, and a Boolean member variable isFrameStarted initially equal to false. Okay, almost finished. We just need to add some public getter functions. First, we have a bool isFrameInProgress. Mark this function as const and return isFrameStarted, followed by the function vkCommandBuffer get currentCommandBuffer brackets const, which for now will return command buffers at currentImageIndex. And I will add an assertion to ensure that the frame has already been started. So include cassert, and then in getCurrentCommandBuffer, check assert isFrameStarted, and with the message cannot get command buffer when frame not in progress. Lastly, the application will need to be able to access the swapchain render pass in order to configure any pipelines it creates. So add a function vkRenderPass get swapchain render pass, and return lve swapchain arrow get render pass. This can also be marked as const. Then create a new renderer implementation file. So I have lverenderer.cpp. And then I'll copy and paste the entire application implementation. Okay, now let's rename every occurrence of first app to lverenderer. Then change the first include to be renderer.hpp. We will also not need GLM here, so delete that, and we can also delete the simple push constant data struct. Next in the constructor, we need to initialize our window and device. So lve window ref window and lve device ref device, and then add a member initialization list with lve window braces window and lve device braces device. Okay, then in the constructor body, remove the calls to load game objects and create pipeline layout. In the destructor, we don't have a pipeline layout to destroy, so you can remove that as well. But add a call to free command buffers. We did not need this before because the command buffers and command buffer pool were both tied to the application object's lifecycle. But now it will be possible that the renderer will be destroyed, but the application will continue. Next, we can delete the run function, and we can delete the load game objects function, as well as the create pipeline layout function. Okay, at the end of the recreate swapchain function, we can't create our pipeline anymore. So remove this function call, and we'll come back to this in just a moment. But really, the render pass we create for now should almost always be compatible, and therefore the pipeline may not need to be recreated. Next, delete create pipeline, and create command buffers can remain as is. I'm going to skip over the record command buffer function for now, and scroll down to remove the render game objects function. Okay, now we still need to implement our 4 new functions we declared in the header. So navigate to the renderer header file, and let's copy these 4 function declarations, and then paste them in at the bottom of our renderer implementation. I'm going to add my class name scope before each function name, and then let's start with implementing the body of begin frame. First, I'll assert that a frame isn't already started, so assert not isFrameStarted with a message can't call begin frame while already in progress. Then I'm going to scroll up to my drawFrame function and pull out the first portion of code up until the call to record command buffer, and I will paste that code into begin frame just under the assert statement. Remove this local uint32 type image index variable, and instead use the address of the current image index member variable as the acquire next image argument. Then update this return statement to now return a null pointer. This will indicate that the frame has not successfully started. At the bottom of the function body, I'll then set the isFrameStarted variable to true. Following that, create a local variable auto command buffer equal to get current command buffer. Then scroll up to the record command buffer function and pull out the first 6 lines that will begin a command buffer, and move them to the bottom of the begin frame function body. Update this argument here to use the command buffer we just fetched. And finally, return the command buffer to end the function. Next, let's implement the endFrame function. Start with an assert isFrameStarted, and with the message can't call endFrame while frame is not in progress. I'll fetch my command buffer and put it into a local variable with auto command buffer equal to get current command buffer. And then scroll up to the end of the record command buffer function and just cut out the last 3 lines ending just the command buffer, not the render pass. Paste these lines into the endFrame function and update the arguments to use the local command buffer variable. Then we're going to pull out the rest of the contents from the drawFrame function, leaving just the call to record command buffer behind, and move that portion of code into the endFrame function. Add the auto keyword before the results variable, and update the argument in the submit command buffers function call to use the local command buffer variable, as well as the image index argument to use the current image index member variable. Then make sure to remove this return statement. To be honest, I don't know why I put that there in the first place. Finally, in set isFrameStarted to false to finish off the endFrame function. So you probably have a good idea now of what the begin and end swapchain renderPass functions will be. I will add the same assertion as the endFrame function, checking to ensure a frame is in progress. But I will also add a second assertion that checks that the provided command buffer argument is in fact the current command buffer, with the message can't begin renderPass on command buffer from a different frame. Next, scroll back up to the record command buffers function and cut out the remaining entire first portion up until the render game objects function call. Then paste that code into the begin swapchain renderPass function just below the 2 assertions. We need to update the getFrameBuffer argument to use the current image index member variable, and then replace these 3 occurrences of command buffers at image index with just command buffer. Okay, almost done. This is the last one. Copy the same 2 assertions from begin swapchain renderPass and paste them in, just updating the error messages. Then all we need to do is copy this one vkend renderPass command, paste it in, and update the argument to be the command buffer. Finally, we can remove the drawFrame and record command buffer functions. Now we can clean up the app header file. First things first, remove the include swapchain statement and include lverenderer.hpp. Next, I'm going to remove all of the function declarations that are now handled by the renderer class. So get rid of create command buffers, free command buffers, drawFrame, recreate swapchain, and record command buffers. Then remove the swapchain and command buffers member variables. And just underneath the device, add a new member variable of type lverenderer called lverenderer that takes the window and the device as constructor arguments. Okay, now navigate to your app implementation file and start by removing the recreate swapchain and create command buffer function calls from the constructor body. However, we need to add a function call to create pipeline, since that is no longer done by the recreate swapchain function. Then scroll down to the recreate swapchain function and we can delete that, as well as the create command buffers, free command buffers, and record command buffer functions. You will also want to delete the drawFrame function. Next, we need to fix up the create pipeline function. This first assertion is no longer relevant, so we can delete that, and then we need to replace lveswapchain arrow getRenderPass with lverenderer.getSwapchainRenderPass. The only thing left to do is update the run function to use our new renderer object. So in the run function while loop, first remove the drawFrame function call and add an if statement with the condition auto command buffer is equal to lverenderer.beginFrame. Remember that the beginFrame function will return a null pointer if the swapchain needs to be recreated. That's why this if statement check is necessary. Then in the if statement, add lve_renderer.begin_swapchain_render_pass, passing in the command buffer as the argument. Next, call renderGameObjects with the command buffer followed by lve_renderer.endSwapChain_render_pass, also passing in the same command buffer. Finally, call lve_renderer.endFrame. You may be wondering why beginFrame and begin_swapchain_render_pass haven't been combined into a single function. And that's because we want that application to maintain control over this functionality so that down the line, we can easily integrate multiple render passes for things like reflections, shadows, and post-processing effects. If you've done this refactor correctly, you should be able to build and run your code successfully and see a green triangle. Resizing should still work just the same, even though we are not creating a new pipeline anymore. If resizing has stopped working, the most likely error is forgetting to remove the return statement just after the call to recreate swapchain. Okay, now I'd like to move all functionality specific to our pipeline and the simple shaders into a dedicated render system class. Don't worry, this refactor will be a lot quicker than the one we just completed. So start by copying the contents of the app header file and then create a new file. I'll call mine SimpleRenderSystem.hpp. Paste the code into the new file, and then I'll rename all occurrences of first app to SimpleRenderSystem. Next, you can remove the include statements for the renderer and window since they will not be needed. Okay, now remove the width and height constants. They are still app specific. And then update the constructor to take an LVE device reference called device and a VK renderPass parameter called renderPass. We can remove the run function as well as the load game objects function. Then update the create pipeline function to take a VK renderPass parameter. The renderPass will be used specifically just to create the pipeline, and we're not going to store the renderPass because the render system's lifecycle is not tied to the renderPasses. Next, move the renderGameObjects function to be public and add a second parameter of type std_vector LVE_gameObject. And make it a reference type called GameObjects. Now remove both the window and renderer member variables and update LVE device to just be a reference type. Finally, also remove the GameObjects member variable. Okay, by now you should be familiar with the routine. Navigate to the app implementation file, copy the entire contents and create a new file called SimpleRenderSystem.cpp. Paste the app implementation code into the file and start by changing the top include from app to SimpleRenderSystem.hpp. Next, replace every occurrence of first app with SimpleRenderSystem. And then update the constructor to take the two arguments, LVE device ref device and VK renderPass renderPass. Then use a member initialization list to initialize the device, so LVE device braces device. In the constructor body, remove the loadGameObjects function call and then pass the renderPass argument into the create pipeline function call. The destructor can remain unchanged, and then we can remove both the run and loadGameObjects functions. The create pipeline layout function is good as is, but below that, update create pipeline with the parameter we added. So VK renderPass renderPass. The only change necessary inside the function is to replace renderer.getSwapChain_renderPass with just renderPass. The last change we need to make is to just update the renderGameObjects function to take the vector reference of GameObjects as the second argument. Okay, now to clean up the app header, we can remove everything that has to do with pipelines now. So this include pipeline.hpp is no longer necessary. And we can also get rid of the create pipeline layout, create pipeline, and renderGameObjects functions. We can also remove the pipeline and pipeline layout member variables. Then in the first app implementation, start by removing the create pipeline layout and create pipeline function calls. Then remove the simple push constant data struct, as this is now located in the SimpleRenderSystem class. Next, remove the vkDestroy pipeline layout function call from the destructor. Okay, now time to initialize the render system. First, we will need to include it, so I'm going to scroll up and add include SimpleRenderSystem.hpp. Then at the start of my run function body, I'll add a local variable of type SimpleRenderSystem called SimpleRenderSystem, and initialize it with myDevice and renderer.getSwapChain renderPass. Next in the run loop, change renderGameObjects to be SimpleRenderSystem.renderGameObjects, passing in the command buffer and the GameObjects member variable as the arguments. Then below the function, we can delete createPipeline layout, createPipeline, and the renderGameObjects function. Look how much simpler our app is now, and we have a clear structure for adding more systems in the future, whatever you may need, be it a different method to render objects or a physics and collision system. Also, make sure you can still compile and run your code as before. Okay, this video is already pretty long, but there are a couple more items I'd like to tackle. I'm going to add a check to make sure the swapchain render pass is compatible when recreated. Otherwise, we will throw an error. So navigate to the swapchain header file, and in the private member variables section, just under the swapchain image format, I'll add a new member of type VK format called swapchain depth format, because currently we do not keep track of that. Then add a public function, bool compareSwapFormats, that takes a const LVE swapchain reference. This will be a const function where we will just compare if both the swapchain.swapchainDepth format equals swapchainDepth format, and the swapchain.swapchainImage format equals this object's swapchain image format. Currently, when the swapchain is recreated, these are the only two values that theoretically may change since the render passes are otherwise created identically. So if the swapchain depth format and image formats are both the same, the render pass must be compatible. So let's head to the swapchain implementation file, and at line 300 in the createDepthResources function, just set swapchain depth format to equal the depth format being used in this case. And since we're already here, I also just recently found a mistake in the swapchain code I've provided. If you scroll up to around line 250, this is where we configure the render pass's dependencies. However, I only did this for the color attachment and forgot about the depth attachment. As far as I know, this hasn't caused a bug for anyone so far, but it could on some devices depending on their graphics drivers. So I recommend fixing it to match what I now have here. If you started following this series after April 2021, the file I provided will already have this correction made. Okay, now moving on. Head to your renderer implementation file, and inside the else block of the reCreateSwapChain function, add at the top a new local variable std shared pointer old swapchain equal to std move lve swapchain. Then in the constructor for the new swapchain, replace the existing move swapchain call with old swapchain. Next, add an if statement that if not, old swapchain arrow compareSwapFormats with the contents of lve swapchain.get, then throw an std runtime error with message swapchain image format has changed. Rather than throwing an error, it would probably be better to set up a callback function notifying the app that a new incompatible render pass has been created, but I'm going to just ignore that edge case for now. The final change I want to make today is to no longer use a one-to-one pairing between swapchain images and resources such as command buffers. We've already laid down a lot of the groundwork to make this change, so it should be pretty straightforward. Open your renderer header file, and just below current image index, I'm going to add a new member variable with type int called current frame index. This will be used to keep track of a frame index in the range of 0 to max frames in flight, not tied to the image index. So add a public getter function, so int getFrameIndex, mark the function const, and similar to the getCurrentCommandBuffer function, this should not be called if a frame is not in progress. So copy and paste this assertion and just update the message to refer to the frame index, and then simply return the current frame index. Then in the getCurrentCommandBuffer function, we will change from using the command buffer at image index to using the command buffer at the current frame index. Okay, now head to the renderer implementation, and in the createCommandBuffers function, change the argument in resize from the image count to lve swapchain max frames in flight. The max frames in flight constant is currently defined as 2. Also, by no longer relying on the image count, we don't have to worry about recreating command buffers when a new swapchain is made. So just above in the reCreateSwapChain function, we can remove these 4 lines. Then finally, at the end of the endFrame function, we need to increment the current frame index. So add the line current frame index is equal to current frame index plus 1 in brackets, mod LVE swapchain max frames in flight. And that's it. Build and run your code, and everything should work just as before, but behind the scenes, everything is much better structured. Check resizing is still working, which in my case it isn't because I missed this knot right here. If I fix that, now everything is working correctly as it should be. I know this was a lot of code, but it lays the groundwork for many future tutorials. As a bonus for getting this far, I created a simple app demonstrating some cool things we can do in 2D already. In the description below, I've included a pastebin link and a patch file. I was originally planning to walk through this code in detail, but this video's gone on long enough. But feel free to ask any questions about how it works in the comments below. All it does is simulate an attractive force between the two objects, and then for each point in the vector field, I calculate the net force and scale and rotate the field lines to point in that direction. Anyway, thanks for watching and keep on coding. Cheers.